Today's lesson is going to focus on rational exponents and the comparison between radicals and how to write them as exponents. So here we have an intro table involving basic three different radicals: the square root of 25, the cubed root of 27, and the fourth root of 16. And just to help you realize that each of these can be written as a exponent power. And so here you see on the first one where the square root of 25 very simply becomes 25 raised to the power of 1/2. The cubed root of 27 is the 27 raised to the 1/3, and the fourth root of 16 is 16 raised to the 1/4. And so the denominator of that fraction has to do with the root, remembering that this is an invisible 2 on the square root of 25. So just realize that you can rewrite those as a fraction. We've done that before in our calculators, but I wanted to review that idea as we start today's lesson. Our basic rule for today talks about how we convert back and forth between rational exponents and between radicals. And we have a to the raised to the 1 over n equals the nth root of a. So that could be the half root, the square root, or the cubed root, or the fourth root, or the fifth root, or anything. And then secondly, a raised to a fraction, m over n, is equal to the nth root of a raised to the m, or the nth root of a with parentheses to the m. So we've got 4 different little examples here just to go through as some practice and to show you how you simplify these problems. So let's look at our 64 raised to the 1/3. Well, the first thing I'm going to do is I'm going to think 64 is really 4 cubed. And so we're going to have 4 cubed to the 1/3. We come over here to our rules of exponents, and a power to a power, we multiply our exponents. And so that's our first rule. And so we have 3 times 1/3, which is 1, and so my answer is 4, because you also know that the cubed root of 64 is 4. And that's the reason why that it's 4. Let's look at our second one. We have 7 to the 1/2 times 7 to the 1/2. Well, this involves the very simple idea of a to the m times a to the n, and we add the exponents in this case, and I hope this little chart over here is a good summary chart. So we multiply the bases, we add the exponents, and so here we have 7 to the 1/2 times 7 to the 1/2 is 7 to the 1/2 plus 1/2, or 7 to the 1, or very simply 7. Now, translating, you realize that that's the square root of 7 times the square root of 7, which is the square root of 49, which is 7. So that's the radical way to think through that, but we really want to think exponentially today. Let's look down at C. We have 5 to the 1/3 times 25 to the 1/3. Well, we can't combine them unless the bases are the same. So I'm going to rewrite the 25 as 5 squared to the 1/3. And then I'm going to rewrite that squared to the 1/3. And I'm going to multiply 2 times 1/3 to get 2/3. Now I have the same base, so I can add my exponents. 1/3 plus 2/3 is 3/3, which is 1. So we have 5 to the 1, or an answer of 5. Okay? All right, let's look at D. Let's use these same ideas. Let's write both of them as 2 to a power. So here we have 2 to the 1/4, and 8 is 2 cubed raised to the 1/4. So that's 2 to the 1/4 times 2 to the 3/4. 1/4 plus 3/4 is 1, so my answer is just 2. So that's just a couple quick examples how to deal with fractions as exponents and simplify them using exponents but not using radicals. Let's look on our second part. Here we're going to convert from exponential form to radical form, just as some practice. Now, remembering our basic rule that says x raised to the a over b is equal to the bth root, that's kind of weird, the bth root of x to the a. So here we have x to the 2/7, so that would be the 7th root of x squared. On b, it's a little bit different. We have x to the negative 0.4. Well, first of all, that's 1 over x to the 0.4. we can think about what is 0.4. Well, 0.4 is 4/10 or 2/5. I guess I can take some steps in writing this. So 1 over x to the 2/5. So that is the 5th root of x squared in the denominator. Here we have x to the negative 3/4. So that's 1 over x to the positive 3/4, which leads us to 1 over the 4th root of x cubed. D, x to the 2.5 is really 5/2. So that's the square root of x to the 5th. Realize I do not need to put a 2 in my problem. So here's some examples of converting from exponential to radical. We really are just trying to get comfortable moving back and forth today and simplifying. Now let's go the reverse way. Let's go from radical form to exponential form. Remember, a root of 4 becomes the fractional dividing by 4 in our exponents. So now we have c to the 3rd raised to the 1/4, or c to the 3/4. Here we have b to the 1/3 raised to the 5th, or b to the 5/3. Here we say we have 5a to the 7th all being taken as square root. So that's 5a to the 7th raised to the 1/2. So that's 5 to the 1/2 times a to the 7/2. Lastly, over here on D, we have 5x squared raised to the 1/3. So that's 5x to the 2/3, or 5 to the 2/3, x to the 2/3. Okay, so that's just some simple illustrations of how we're going to simplify and work through raising exponents to radicals, radicals to exponents, and then also simplifying numbers. And the key idea on simplifying numbers is writing them with the same base before you combine your exponents. I hope this has been helpful. Our homework assignment is down here, 1 through 25 all. And I encourage you to look back at your notes when you get stuck on these problems, if at all. Take care, and I hope this has been great.